Hello, class. Let's talk about transformations right now. And then after we do that, I'll do this problem last, the piecewise defined functions. So let's just stick with transformations for now, and then I'll do that piecewise right after. So transformations, there's a lot of different transformations. Let's do this one first. Um, we got to remember our library of functions. I should have written those down like y equals x squared. That's in our library of functions. Isn't that the parabola, the squaring function that's called? Y equals x. That's another one in our library of functions. And it's a diagonal line through the first and third quadrants. That's y equals x. The quadrants are labeled, by the way. 1, 2, 3, and 4. I don't know why, but we use, by tradition, Roman numerals. So that's always the first quadrant in your rectangular coordinate system or Cartesian plane, whatever you want to call it. So these are nice to have memorized because they're such common graphs. Like, what's another one? How about y equals x cubed? What does that graph look like? It looks like this. Notice it's got a curve to it. So that's y equals x cubed. And, okay, so there's a few more, but I have them listed on my lesson plan. So check out Learn, because I already put them on Learn. Okay, so when we look at this, we want to graph this in stages. That's going to be the direction. I'll say it again. Graph this function in stages, starting with the basic graph, which means from the library of functions. So I see an x and I see a square. So I realize that my basic function is f of x equals x squared. So what does that graph look like? And we should have that memorized. It looks like that. If you don't remember what it looks like, though, you can always do your table of values and come up with points. Like, for instance, for this one here, if I let x randomly equal 0, what is 0 squared? Isn't that 0? So that's the point on the graph. In fact, it's right there. And then what happens if I let x equal 1? And what's the output going to be? 1? What happens if I let x be negative 1? What's negative 1? All squared. Positive 1. And indeed, those points are covered right here and there. So that's y equals x squared. Notice we just have one transformation here. And what is that going to be? That's called a horizontal shift. Whenever your number is right inside the function, right inside the parentheses, that means a horizontal shift, which means we're going to move this graph 2 units to the left. It's the opposite of what you think. So it's a little tricky. So now we're ready for the whole enchilada because, again, all we had was one transformation there. So what is this graph going to look like? And it's going to look remarkably like the prior graph, except we're going to shift it. Oops, let me see. Let me call that f of x plus 2 all squared. Yeah, so let me go x plus 2. That's what I meant to do. What does this graph look like? And it's going to look remarkably like the prior graph, except we're going to shift it 2 units to the left. So you got to remember, with the horizontal shift, it's tricky. You do the opposite of what you think it's going to be. So watch how quickly we can graph this. Just 2 units to the left, just like that. And there it is. The horizontal shift, that means, in this case, subtract 2 from all x coordinates. That's how the horizontal shift works. It affects previous x coordinates. So, for instance, if I go back to my basic function, and I label this point, say, 0, 0, which is the vertex, what is that vertex going to transform to over here? So subtract 2 from all previous x coordinates. What's 0 minus 2? Negative 2? So doesn't that vertex now look like it's negative 2, 0? So that's the horizontal shift. How about if we were asked to do, instead of graphing this function, we were asked to graph this function. F of x equals x squared plus 2. So notice, isn't this one look a little bit different from the one we just did? Notice the 2 here is right inside the function, inside the parentheses. But this 2 is in right field. And when it's in right field, it's called a vertical shift. This is a vertical shift when the number is outside of the function in right field. As where when it's right inside the function, that's called the horizontal shift. Horizontal shift. So what is this graph going to look like? So again, you got to realize which basic function from our library of functions is it closest to. Well, I see an x and I see it squared. So is it this going to be the basic function then? F of x equals x squared? And we know what that graph looks like. It's in our library of functions. It looks like that. And now we want to graph this function, which was given. So again, you start with the basic function, and now we only have one transformation, the vertical shift. So this affects the y coordinates, or the y-axis. So all I'm going to do then, to go from here to my final graph, which I'll write as f of x equals x squared plus 2, what is that graph going to look like? It's going to look remarkably like the prior graph, except we're going to lift up the graph 2 units upward. The vertical shift is very honest. Since that's a plus, we're going to lift up the graph about the y-axis. So it's going to look like that. If I go back here and label 0, 0 in my basic graph, that's right there. What is that vertex going to transform to when we do this vertical shift, where we lift it up 2 units? This says add 2 to all previous y coordinates. So what's 0 plus 2? 2. So this new vertex is 0, 2. 0, 2 is that new vertex. Let's do the domain and range for this final graph. What's the domain going to be? It's going to be all real numbers, because doesn't this parabola cover the entire x-axis? Like this part here is going up forever, but also to the right forever. So it's covering this entire x-axis over here. And similarly, this branch is going up forever, but to the left forever. So it's covering this part of the x-axis. So all real numbers for the domain, because if I were to draw a vertical line on the x-axis, wouldn't it hook up with the graph? And yes, so that means the domain's all real numbers. What's the range for this graph? The range, think of the y-axis. I should have really labeled my axes here. Think about the y-axis. What part of the graph is being covered by this graph? And so that means you kind of think about drawing horizontal lines on the y-axis. And if your horizontal line hooks up with the graph, that means that that's going to be in the range. Notice down here, if I draw a horizontal line, it will not hook up with the graph. So that's not going to be part of the range. In other words, there's no value that's going to occur here for this function that's going to be less than 2. That's the y coordinate. And like, in other words, 0 or -1. Y can't be -1. Let's see, why can't y be -1? No matter what you plug in for x, even if it's a negative number, when you square it, doesn't it become positive? Then you're adding 2, so we can see like it's impossible to get -1 as an output. And that's reflected by this graph here. So the range, look at the smallest y coordinate, which is right there. And always go low to high with these. 0, 2 is part of the graph. It's that vertex. So square bracket. And then remember, range, think y coordinates. So 2 to infinity. That is the range for that graph, where y is greater than or equal to 2. Okay, so that's a good little thing about transformations. And there's more of them, as you'll see in my notes. I'll do one more. How about y equals, say, -x squared? What is that graph going to look like? Well, it looks like the basic function is the parabola again, but we only have one transformation, and when you have a negative sign outside the function, it's a reflection about the x-axis. So let's do this in stages. Y equals x squared, and that graph we know looks like this. And then, what is y equals -x squared? It's going to look remarkably like the prior graph, except we're going to flip it about the x-axis. That's what happens when the negative sign is outside the function. You flip it about the x-axis, so it's going to look like that. So we can graph these things quickly now that we know transformations. What's the domain for this function? Can you tell it's all real numbers? Doesn't this parabola cover the entire x-axis? And what's the range here? The range, go low to high. And notice, with this y-axis, isn't this, like if I draw a horizontal line here, doesn't it hook up with the graph eventually? Sure it does. this part too, as a matter of fact. So the range is going to be, go low to high, so it's going to be negative infinity to, what's the highest y coordinate? Isn't that going to be 0? Square bracket? So that's the range for that y equals negative x squared. I could also write it like this. Use the variable y is less than or equal to 0. Okay, so that's good for the transformations. You know what? That's good enough. I'll do the piecewise defined function another day this week. But this will give you a good taste of what you'll be seeing very soon for my next video, piecewise defined functions. That comes in about a couple days from today anyway. So, good enough. See you next time.